Hello, welcome everyone. Welcome to today's webinar. We're going to be talking about off-grid systems today. My name is John Hay, and I'm with Nebraska Extension. We have a couple experts on with us today. We have John Dixon from Dixon Power Systems and Scott Williams from Green Tech Renewables. And we're going to be talking about off-grid systems. So I thought I'd just give them an opportunity to introduce themselves briefly and tell us about their off-grid experience. Go ahead, John.
Uh, Good afternoon, I guess it is to everyone. I'm John Dixon, Dixon Power Systems. I've been doing solar for right at 25 years now. Prior to that, I was an automotive mechanic at an automotive repair shop. Um, so right now I do grid-tied solar, used to do a fair amount of wind generators. And I also have a handful or so of off-grid homes, as well as I do a lot of specialty equipment, things built for specific industries that are solar powered. Um, and my father was an electrical engineer, so I have what I consider at least a well-rounded area of expertise.
Very good. Scott.
Thanks, Sean. I'm Scott Williams. During the day, I am the Business Development Manager at Green Tech Renewables Omaha. We are one of nearly 100 locations nationwide. We work in wholesale hardware distribution. So on the other side of the camera is a warehouse full of solar panels, inverters, racking, and then all the rest of the bits and pieces to be able to build solar energy plus storage systems. Our work is typically in residential and small commercial, up to maybe about 10 megawatts. Hardware distribution would add value to a project. In terms of off-grid projects, I have been dabbling, tinkering, DIY-ish related to off-grid type of work. I built a little off-grid system in a community garden. We did the same in a city park, just to provide a small amount of electricity for some specific needs at those specific places. I have been involved in projects here at Green Tech that have gone all the way to the other end of that, including a client who built an entire off-grid home because the cost of the grid connection was way more than just building solar and storage and doing it himself. So from the smallest of projects up to, essentially complete full electric installation service. And I'm looking forward to talking about it with you both.
Yeah, great. I think that's a good point that you made. This idea of why are people putting in off grid? There's different reasons, and one of those could just be access, right? Cost of access, and there are some definite reasons for that. The last webinar we talked about backup systems. And backup systems are a little different than off-grid, but one of the things that was noted was the importance of defining the outage that design is being made for. Well, I think that idea of defining the outage is relevant here as well, but maybe call it defining the load. And so what load is this off-grid system trying to serve? And that's going to impact the design. And where you mentioned these maybe a very small system that might be running a light or a series of lights versus a system that is running a whole home, those are different animals, and they have a lot of different components and a different scale of components. But I think we have two experts here that are really versed in solar, but I think that we're going to bring in all of the different components, including generators and other things into that. So it's a little more complex than just solar or batteries or something like that. Let's start with this idea of defining the load. How would you recommend, or let's talk about what you might tell somebody if they came in and says, I want to go off grid. These are my reasons. And, how do I get started? What might you start with?
So if they come in and talk to me about that, they've given the reason. That's always the one thing you like to find out first. Why do you want to be off grid? Whether it's the cost to bring it in or you just want to do it, whatever it is. You do have to define the loads, but you also need to look at the home and how you're going to operate it, because there may be appliances in the home that you're also going to change. Well pumps, you might go to a constant pressure pump so you don't have surge loads. Heating and cooling, heating for sure, propane. Whenever you get into off grid, you become your own utility. So you're going to be the guy that's going to get out there when it's -4 degrees and snowing if there's an issue, or the gal. So that has to be taken in. You have to really understand that you're going to be doing load management. You're going to be watching the weather. You're going to see what your state of charge is. Do you need to run the generator now so it doesn't try to come on at 2 a.m. when you're asleep? These are the things you need to be thinking about as in a mindset. Off-grid really is kind of a lifestyle change. And as you say, you have to define the load. So in this case, it's listing every single thing you're going to be running in that house, making a list, putting wattages next to them, surge capacities next to them, and all those things then keep getting transferred as we go through this design process.
Like we mentioned last week, I would encourage people to keep in mind sort of that electricity 101, which is that we have both instantaneous load demand, right, in watts or even kilowatts, which is how much stuff you can power at any given instant. And then we also have energy over time. So if you want to power a kilowatt for an hour, we conveniently use a unit of measure, which is very strangely unscientific, but we conveniently use kilowatt hours. And so there's both instantaneous power and then energy over time, because one of the most convenient and cost-effective ways to get energy at any location is with solar generation. You essentially just take a sheet of glass and point it at the sky, and you have electricity when the sun is up there. But it is true, the sun is not up there all the time. So you might have a generation peak or a generation profile, and you need to match that against your load profile. So both instantaneous demand and then storage to be able to take the energy made from solar and spread it out. Or, as was mentioned, you might be adding additional resources like generators, right? But every minute the generator runs, it's using fuel that you got to buy and is in finite supply. So balancing those things out to try to make sure that the project accomplishes all of the goals is essential upfront, to make sure there's reasonable understandings of load and energy, what kinds of resources you have, and what it is you're trying to accomplish.
You mentioned load profile, and when I think about solar, I think it kind of looks like a bell curve if the system's not moving. But then I also think about what does it look like on a day that is not sunny, and it might be a broken, system that it's not getting as much. And so we have both what it could generate, but also what it will on a given day or week or month. And so let's talk a little bit about the seasonal patterns and how maybe a system, an off-grid system, is planned for related to that seasonal pattern. So solar production is best in the summer when at least in Nebraska, where we have long sunny days, and least in the winter when we have short, sometimes cloudy days and snow and other things. So let's talk a little bit about season pattern planning for that.
Sure.
If you're using, I'm sorry.
Go ahead, John.
No, I'm just saying. So when you're doing the off-grid, as we're talking today, and your solar is going to be your main charging source, you always have to design for worst case scenario, worst time of the year, which is December. You're only going to get less than half the generation. So solar's nice, but it isn't the greatest choice for wintertime production because its production is at its lowest curve. The other thing that happens in the wintertime, what happens? We could have 10 days of socked in overcast. You could have snow. So rooftop solar for grid tie is not a great choice because you have no way to clean the snow off of it, keep things going. So ground mounts are always your preferred, at least, choice. So you're always designing for the worst case scenario. So it's always going to be December. So you're going to be looking at your December loads. You're going to be looking at December production. You're going to have to make adjustments to the solar to compensate for that. Production in anytime you're doing solar as this type of a project, you're always going to design at least half again, if not twice as much generation as you actually need on a daily basis. As John was just talking about, you're going to see your solar energy go peak, then clouds are going to come over, go up, down. Maybe it's a day where you're only going to get 30% of your capacity. That's why you always have to have extra, as well as in any full-time off-grid, you're always going to have a generator. You can't necessarily get around it unless the customer is willing to really take extreme measures.
Yeah, I do agree with John that the production is worse in December, but production is not the only consideration, right? Seasonal temperature lags behind the solar cycle. So while you might have slightly better production in January or February, you might have slightly more demand because it might be colder. So there's both a production and a demand sort of consideration. Um, but I agree that, yeah, the sun is the lowest and the quickest across the sky in December. And so it's good to keep in mind how the sun moves through the sky as we think about how solar production will go. I am involved in a very large, it's not off-grid, but it is a resiliency backup microgrid. And the design criteria are for 100% of energy needs for 48 hours. And we have to assume no solar generation at all. So we have to use the winter months as the baseline. And what that means then is because we get significantly more solar during the summer months, there will be significant overproduction of solar as a result. If you want 100% at the lowest, then your highest peak is going to be significant overproduction, at least for flat annual demand. And in this case, the load is so large that it is essentially flat annual demand. Yeah.
Yeah. No, I think that's really important to think about, that it doesn't, solar isn't necessarily the greatest fit for year round. And then the trade-offs of trying to figure out how we're going to design a system with that, and what else we're adding. So let's talk about components. We mentioned generators a little bit. Let's just make sure we get a list of the components of an off-grid system. And we can include, let's think about that as a solar off-grid system, but we could add other things if we want. But, we have a generation system, and then we have batteries, but there's some things in between, and some things on the other side of the battery. So let's just make a list of those. And, Scott, give us a start on that, and let's see if we can get a list.
The solar panels are your generation source, and they will take light energy and turn it into direct current. And so you will have DC from your solar panels, and you will need to do something with the solar. Most of the time, you essentially have to have storage. So the next thing from the solar is oftentimes a charge controller, which will connect the solar to your storage, your batteries, right? And so you can have, depending on how the system is designed, you can have DC solar and DC batteries, and then you can come off of that DC and have an inverter that can create AC for the types of appliances you may be using, right? Outlets or Wi-Fi routers or TVs or common household appliances are mostly ready for AC because of the grid. It is worth keeping in mind that depending on how the project is designed, you could be shifting some or maybe a lot of your load and energy use over towards that DC, right? That's exactly what we see in RVs. And RVs are essentially a kind of off-grid energy system. So they have all the components there. They often will put solar panels, charge controller, battery, inverter to get some AC, but a lot of the loads might be shifted over to DC because going from AC to DC through an inverter has some losses. And so if you can shift, for example, lighting, you can get 12 or 24 volt lighting over onto the DC and avoid some of the losses, because if you have finite resources in terms of power and energy, you don't want to be frivolous with what you have. And so losses in inverters might be more consequential in off-grid systems. But yeah, that's sort of the panel, charge controller, battery storage, inverter, essentially are the components. John, have I missed anything?
I think we've gotten the major parts. What about any of the balance of system parts that we might just rattle off here a little bit?
Well, depends a little bit on the type of system, but you're going to have battery cables, you're going to have fusing, you're going to have PV combiners, you're going to have DC disconnects. Obviously, you're going to have a generator, so you're going to have some type of generator control, assuming it's a generator that can be started automatically. I don't know, that's kind of the round. You're going to have monitoring, whether it's you have to have at least minimum monitoring, local monitoring, but online monitoring typically is what most people will do, which will give you monitoring. And depending on the type of equipment, it'll give you control where you can change settings, change parameters, whatever all needs to be taken. Two-way control is a really nice bi-directional operation.
Depending on
I think that's good. Good. Go ahead, John or Scott.
Depending on how much AC electrical service you're providing, you might have some AC electrical components there too. If you have a significant amount of power, you might need to have, a service panel with different circuits and circuit breakers to spread that panel, the electricity through maybe the home, while maintaining safety, right? If we have AC circuitry, we need to continue to meet, electrical code in order to stay safe. So, service panels and breakers. There might also be, on both the DC and AC side, you might have disconnects to be able to separate out the system in order to make sure that it's operating safely in order to do work or maintenance or changes. So you could have DC disconnects and maybe an AC disconnect, again, depending on what's on that side of the system.
I really like this list, and I like that it's both the major components, but also we listed some of those minor components, because I think about, those systems going in, and you got the big boxes, okay, but there's lots and lots and lots of little boxes of all those other little details. And I think that this is why it can get challenging and complex. And also, when we're doing this, we're trying to also meet those safety parameters and what does the electric code say about this and that and the other thing. And so there's lots of conduit and other types of boxes and things like that. So just remember that it's not just the major components, it's lots and lots of things of those going together as well. Let's just, I want to discuss just a little bit about battery sizing. How do I know that battery is the right size if I have a system with let's say solar with a battery and then a backup generator? How do I know that's the right size?
So when you're sizing the battery, first you got to come up with a load. So we're going to say we need so many kilowatt hours a day. Then you're going to look at your battery. Well, not then, it's not a particular order, but you're going to look at this battery. You got these kilowatt hours you need. So now you're going to need some battery to take care of that. So you're going to take this battery and you're going to say, okay, I need whatever the number is of kilowatt hours a day. You have to ask yourself, well, today it's sunny, tomorrow it's going to be overcast. How many days of overcast or no solar production do you want to sustain with your batteries before you start to generate? And that answer will be 100% customer based on what they want to do. The one example Scott gave for that other company was 48 hours, even though it's not an off-grid deal. But so maybe your customer says 2 days. So you're going to take those kilowatt hours, you're going to take it times 2 days, you're going to put in efficiencies. You always calculate the additional capacity for efficiencies and losses, whether it's inverter, battery, wiring, cabling, all those efficiencies. And then you're going to put in there a state of charge. How low am I going to discharge my battery? And you put that in there, and then that's how you come up with that particular number. Now you have a baseline for a battery. But you have to remember, if you have an inverter, that battery has to be able to supply enough capacity to run that inverter size. So it still has to be double checked against that. And then if you have solar, you can only charge that battery so hard at such a particular current rating. So now you have to double check it against your solar. So you're basically coming up with this, okay, here's what I think I basically need for a battery, but there's a whole lot more that goes into the sizing of that battery as we start to look at the other components.
One of the things that I mentioned in last week's webinar, which was backup, which is essentially kind of like a very short-term off-grid system. One of the things to keep in mind is that you have some trade-offs between user behavior and technology. There are smart technologies or other kinds of things that can help assist to do things in a sort of an automated way, right? The depth of discharge on a battery, there's a certain level under which you will be damaging the battery if you continue to try to pull energy out of it. So you could have, low voltage cutoff to make sure the battery doesn't discharge so low that it might be permanently damaged, depending on the battery chemistry, right? And that is a very simple example of something that almost certainly you would want to rely on technology rather than user behavior. You wouldn't want to constantly monitor battery state of charge and then go shut everything off when it gets down below, 2.6 volts or whatever. But in more complicated systems, you could watch your battery creep from 100% to 0, and you might say at 100%, I feel pretty comfortable doing things that I kind of want, right? I'm going to run the space heater or whatever because I feel like this is only giving me an hour or two. We're going to be fine. but maybe that in an outage, right? But in an off-grid situation, you need to constantly know, well, as the battery state of charge gets lower, am I going to be able to bring generation resources online, solar and or wind and or combustion generators, or am I going to change the use patterns, right? And so once again, if it's an AC system, you might have things like smart breakers that might try and turn circuits on or off, or other types of monitoring that could nudge user behavior to say, hey, you're really cruising through your battery here. Do you really want to fry that turkey right now? Or do you want to maybe, or do you want to dry your clothes right now when it's night? Or do you want to wait until tomorrow when there's plenty of sun available and we have excess energy to be able to do what it is that you're doing with the energy?
I think this idea of lifestyle off grid and how we design the system also influences that, right? Because I could design my system a little bit smaller and maybe a little less costly if I'm willing to go through more extreme measures with respect to my behavior. But if I really don't want to change my behavior, this thing might not be big. We mentioned a generator because I think that one of the more common methods of getting to those worst times of year is to have a generator that kind of gives us that backup. So the solar and the batteries does most of it, but then that generator is there to kick in and make sure that it functions through that time. But there are other ways to do this. And you mentioned one, and I want to bring it up because I want to talk a little bit about the pros and cons of adding maybe a small wind turbine to this system. Because I think there are some pros and cons to that situation. So let's just talk about that a little bit. What are some of the pros and cons of adding a small wind turbine into this system?
There really isn't anything you can add today. That's the biggest con, unfortunately, especially with the addition of lithium batteries because the charging parameters are so strict, and you can't exceed that. Most small wind turbines that are in off-grid situations were designed for lead acid batteries, and so the control of full can be a little bit lenient. In other words, the battery can drift a little bit over your shutoff parameter, but you can't do that with lithium batteries. The battery management system will just turn the battery off. So it's very hard. I mean, I don't have anything to sell anyone at the moment for small wind to do off-grid with lithium batteries. Unfortunately,
we don't do any wind in our office, but I will make the theoretical case at least, right? From a whole national electric grid perspective, a balanced generation portfolio is essential, right? And in the broadest of senses, solar and wind can be complementary, right? The solar is essentially that bell curve through the day, whereas the wind has a lot more, on average, you get wind more through the times when the solar is not strong, right? And so at the huge scale, like at the grid utility scale, a balance of solar and wind can be accomplished. That doesn't translate super well to very small or even sort of off-grid systems. As John said, it's a challenge to find hardware, not least of which because it has been pretty robustly demonstrated that mechanical issues and maintenance with small wind turbines are challenging, and the cost relative to the benefit, depending on how you evaluate the benefits, has just proven pretty challenging. So the market is pretty narrow. There aren't a lot of choices. So as a consumer, you can't, you don't have 53 different small wind turbines you could select from with robust, manufacturing and service to be able to support them. It's a pretty thin market because at this scale, the balance is not particularly strong relative to other things like solar panels and then combustion generators. Between those with storage, the benefits of the wind are not zero, but challenging to realize cost effectively and reliably.
Yeah, back when we were doing like my lead acid off-grid homes and the small wind, that is the absolute sweetest deal. Their generator never ran. It was the perfect scenario. So small wind is fabulous for off-grid. And if we could get something, I would be pushing it because not only does it runs at night.
Yeah.
I mean, it is the best. Small wind as it is at its peak production when solar is at its
Yes.
lowest. And then they are flipped the other direction. So it allows you to install less solar, less batteries, and still maintain the need of the customer. It is great. There's just, I don't have anything that I can offer a particular person. And the thing to remember when you're off grid, you're your own utility. There's no one to call. When the power goes out, you got to deal with it. When the generator didn't start, you got to deal with it. When there's no sun for 2 weeks, you got to deal with it.
No.
You don't really need smart breakers and things to shed the loads. Any system that is properly designed always has a low battery cutout. So you never have those issues, of course. And of course, with lithium, you can never take them to zero. But all that's put into the design side of the program. So you just have to, I prefer the customer to be doing the load management, paying attention to how their system's operating. Once again, they're the utility, right? So the utility right now is managing their system. They're looking at it, they're tweaking it. You need to do the same thing. I'm not saying you're doing it every day. Don't get me wrong. But when you see the forecast of 3 days of overcast and snow or extreme temperatures, you can make adjustments. You're going to make predictions. Oh, well, here we go. You're going to make hay when the sun's shining, but at the end of the day, you want that battery full, especially if you're going into overcast weather or if you can't run through the night potentially. So it's good. You're the person. So you got to want to do this. You got to want to make it. And you have to figure out who's going to be the button pusher in the family.
Yeah.
Someone's got to push buttons. Someone's got to do these things. And so you need to figure out who that person is. And surprisingly enough, the majority of the time it is the wife.
And I do agree with John's assessment there, but I think it's worth keeping in mind that there are, in the marketplace, there are technologies that are being offered that make promises about nobody needs to be the button pusher, right? And I think that's it. You should be aware that there are people who will offer you technologies to try to afford that convenience. It does exist. Is that the right solution for you? Oftentimes not. The expense and the complexity oftentimes outweighs, hey, I can turn the light off myself. But it is, the convenience factor. I mean, smart homes and the advance of technology is, we live in a technocratic paradigm. There are people who will tell you that technology is the solution to everything, and you don't have to be a button pusher. Tech can solve it for you. But that might be overpromising and under-delivering in some of those situations.
Well, we've seen some of these industries talk about, no planned maintenance or words like that. And you say, okay, well, that's great, but things require maintenance when they don't work. And solar is a good example. Solar, has very low maintenance, but things happen, right? And so obviously monitoring that's important and other things. But let's just talk a little bit about an off-grid system and what are some of the kind of main maintenance issues that somebody might, end up doing, and if they lived in an off-grid home for a year or more. So what are some of those things? And I'm thinking about maybe it's something with the solar, maybe it's something with the batteries, maybe it's something with the backup generator or something like that. So talk just a little bit about any thoughts on that.
One of the ones that I've been thinking about this week, and I've talked to customers who have residential rooftop solar, grid tied, but still, is you got snow on the panels. Is it worth 10 minutes to brush the snow off the panels in order to get your generation going again? That is the kind of thing that you might occasionally do as sort of routine maintenance or upkeep in order to try to keep the system working, because there are many situations where snow could pile on the panels during a time when sun would otherwise be shining on the panels. So that's one kind of thing you might do.
And designing them so we can access them to be able to do that. Because I do tell people, if it's on a roof, don't get on the roof. You don't need to be on a ladder in the cold. But if you can access it with a blower, it's on the ground mount. So make that thought process.
30-foot rake. People try
Don't
stuff to
bang
keep the
on
snow. Yeah.
And don't bang on it. Yeah, for sure. we'll just assume off grid. This is a home, so in my opinion, you would like to have a ground mount, and typically off grid homes aren't going to be in the city, so you're going to be out somewhere. So you with that, you might be changing the angle of the panels if you have an array that allows you to do that 3-4 times a year. Obviously, the cleaning, whether it's snow or dirt, a couple times a year. The batteries, there's not a lot to do with the lithium batteries. Obviously, generators, sure, you're going to do your oil and your service work to that. Just kind of inspecting things, but if it's a quality installation and everything's done really nice, it's really going to lower that, and quality products. But you could still have a component failure that you need to address. And that also goes towards your design. When you're designing something like this, are you designing a system with one component? And if it fails, you lose everything. Or do you have multiple charge controllers and multiple inverters? In other words, you have backups to the backup. One charge controller goes bad, it's no big deal. You turn it off, you get it changed out, but you're not in a dark situation trying to figure out, is your generator capable of bypassing your inverter? Did you put an inverter bypass in? If your system goes down, you flip it over, you run on the generator, you deal with the other. Once again, you're not in a dark mode. You're not sitting in the dark, freaking out, and you've been, you know how to make those changes. At least it is the bare minimum. How do I get the generator started? How do I do this?
One of the things that solar sometimes runs into, non-zero amounts of times, is critters. Right? Depending on how you manage the cables underneath the panels and then into the house, your cable management scheme may or may not allow for critters to get into places and be involved in your systems, right? I mean, squirrels and raccoons get into places, and how much effort do you put on critter control, right? For example, a shingle-mounted solar array leaves a little space where maybe critters want to get in there. Birds and squirrels and raccoons can. You can try and include critter guard or other types of things to keep people out, and your cable management can be done in trays, and maybe your wires are running in conduit to help mitigate that. But it's one thing that, every once in a while I do see an example of, here's some animals getting into a place and being involved in your technology in unfavorable ways.
You mentioned critters, and I think that brought to my mind this idea of where does this equipment live? And I think that that's important because there are some limitations on where a battery can live, as an example. And obviously, a generator needs to be outside where it can vent its exhaust outside. That battery might have to be in a conditioned space. Are there situations where it always has to be in a conditioned space, or sometimes has to be in a conditioned space? What about the batteries a little bit on that?
Well, yeah, so lithium batteries, they have temperature ranges for storage, and then they have temperature range for operating. So all lithium batteries, pretty much, you get below freezing and you could still discharge the battery, but you can't recharge it at full capacity. You can only charge it at a very limited capacity. So a lithium battery needs to be in a controlled space. You can get lithium batteries that have heaters in them, and they can be outside. But generically speaking, the other thing is electronics. If they're at a controlled temperature, if you kept your electronics at 78 degrees year round, you're going to get the most life out of them. That's the way it is, you see. You're not always going to be able to do that, but if you put the battery outside in Nebraska, it was exposed to 4 below. If your battery had a heater in it, which would keep the internal temperature up so that you could fully discharge and fully charge it, fine, but you're still putting some stress on it, If it's in your attached garage, chances are you're not going to get to a freezing temperature in there. But you do have to look at those things, because you might be buying a battery that doesn't have a heater, and you may be putting it into a space that will allow below freezing temperatures. And now all of a sudden you have an issue with your components. So, you're back kind of to the design, as John says. Where are you going to put these batteries? Where are you going to put all of these components? Scott, where are you going to put this? Are you going to have critters? Do we need to address that? there's lots of things to always consider in the initial design. Is it going to put all your batteries and equipment in a standalone structure to make it easier code-wise for you, to eliminate having to do some extra electronics? So there's different things, but yeah.
I will point out that manufacturers manufacture hardware to serve markets, and Nebraska only has about 2 million people. California has 60 million people. So just in terms of size of market, there is more stuff going to California than there is to Nebraska. And so products are manufactured with the markets where they intend to go in mind. And so I regularly see on spec sheets things that are outdoor rated. And I consistently talk with manufacturers and say, I see that you say that this is outdoor rated. I live in Nebraska. I want you to know that outdoors might be minus 20 degrees F for maybe 2 or 3 days. Are you serious about outdoor rated? And most of the time they say, well, so even if something says outdoor rated, it's worth keeping in mind. Yeah, it could be outside, but is it good to be outside? Or is there a way we could try and give a little bit of help, a little bit of protection here? Depending on the size of the system, specific structures, right? You could build a specific structure for inverter and batteries, right? Little shed, shack, tough shed, something that would just give a little bit of environmental control to try and keep your investment away from minus 20 degrees or the sleet or, 2 feet of snow, right? Or the raccoons or the deer that are trying to run into it. So if you can, depending on how much you're investing, how much do you want to protect it, right?
And, the great thing is, as Scott said, manufacturers will say, well, this is rated for outdoor. So when you look at a spec sheet from a product, that's a starting point. That gives you a general idea if this product is going to possibly be a choice for your project. The next step is you have to read the installation manual from front to rear, because that's where you're going to find things in there that say, just like I read a manual the other day that says you can do AC coupling. And I was like, okay, well, this project I'm looking at, that might be, maybe this is a choice. But when you read the manual, and because this was going to be only AC coupled, it specifically states in there, we do not recommend only AC coupled solar to this particular all-in-one inverter. So spec sheet is the starting point to see if this product's even possibility to use, and then you read the full manual. And then if you're really good, you're going to go read the full warranty manual, because then you'll also understand, because many times operating parameters are changed or specified in the operating manual that are much, much lower than what the spec sheet says.
This is excellent. I think we need to kind of wrap up our time here. Is there anything we missed that you think needs to come out with respect to off-grid systems that might be some piece of advice or some component or something we haven't talked about?
One of the things I mentioned last week, and I'll mention again, is try to work with a professional that you can trust. It is true that there are off-grid components that are essentially consumer electronics. You can buy a $50 charge controller from Amazon and have it tomorrow, right? And you can put a couple wires in there with a couple of screws, and that might let a panel make a little bit of electricity and light a light bulb for a little bit. But depending on what you're doing with the kind of system that you're trying to build, right, there is value in working with an experienced professional that you can trust in trying to make something happen. If you're talking about $250 to keep a light bulb going in the shed, maybe you don't need a professional. If you're talking about your whole home and all the things you need to both live comfortably and, the things you want to live comfortably and the things you need to live survivably, right? You might, and this is a significant investment, you want to make sure that it's done correctly and safely, and you're going to get the value from the investment. So I would say working with experienced professionals that you trust is always a good idea.
Yeah, and I just stress the design. You can't put enough parameters into your design. So it's because that's where you're gonna, this is what it's got to do, and now we have to figure out how we're going to meet all of those requirements. Yeah.
Yeah, with both those comments, one of the things I think about is that no, every off-grid system might be there's just quite a variety of them out there, right? There are people that might be making an off-grid cabin that they're living at for a couple of weeks a year. We have maybe an off-grid home where we're living there all year, and so these are different kind of situations, and of course the design is then going to reflect that and how robust it has to be. If I'm only at a cabin for a week or two, the robustness maybe is partially important, but the reality is I could go home when it's done if something goes wrong. While if this is my main residence, the robustness needs to get built in. So again, there's a lot of different levels of consideration there. So thank you very much, John and Scott. Really appreciate it. Excellent job and good conversation.
Thanks a lot, John.
Thank you, Scott.